Hi guys, welcome back to our lesson. We're still looking at revising functions. Specifically, we're looking at questions from past papers to try and see the variation of the questions that they use there and see how do we answer these questions and the types of things that they normally ask. It has nothing to do with what might come in your paper or anything of that sort. It just gives you an idea of what is the style of questioning that you need to be aware of when you are trying to practice your functions. So right now we're going to look at some exponential graphs that are adapted from past papers and try to see how do we actually answer them. And then at a later stage, we'll look at a hyperbolic function. For now, let's look at the exponential one first. Now, with the exponential graph, it says the functions f of x is equals to a to the exponent of x. Already you can see that this simply means that the value of a must be a fraction, right? Because f of x, you can see this is a decreasing function, right? So it must be, the value of a must be between 1 and 0. Already I know that. And then the graph of g of x, which is k over x, will look something of that sort. So that is the same as your hyperbolic function, right? The other arm we know is normally down there, although I did not really show it here. Now, they said x is less than 0. So x being less than 0, it simply tells us that it is in the second quadrant and the fourth quadrant. But they just showed or drew the one on the second quadrant. If point A, right, which is this one, lies on both the graphs, we need to find the value of a and k. Guys, just looking at this already, thinking about I have a point, it lies on the graph. I must find an unknown on the graph. It means I do know what the x and the y is at a certain point, right? Even though I don't know what the other variables are. So what I can do is I can take that point, substitute it where x and y is, and see if I will have one unknown, which is the variable that they might want me to find. If not, then I will attempt another method. But for now, let's look at the one of substituting and see if it will actually work. So we start with the graph of f, right? Firstly, it said f of x is equals to a to the x. We know that a lies on this point, on this line, on this curve, I mean, sorry. So it's a, which is minus 2 and 9. So my x value, you know, will be minus 2. My y value will be 9. So this is 9 equals to a to the exponent of minus 2. And if I want to simplify this, it will be the same as me having 3 squared is equals to a to the exponent of minus 2. But I definitely cannot then drop my basis or drop my exponents because I'm thinking I'm having the same basis or the same exponents. There's nothing that's the same here. I want to make it the same. So to do that, I will make it 3 squared is equals to 1 over a all squared, right, in order to get rid of that negative. Then I will know that my 3 will be equals to 1 over a because my exponents are the same, which will then make a to be equals to 1 over 3. Excuse me, remember what I said. I said a must be between 1 and 3. Is it between 1 and 3? Definitely. So that's what the value of a is. Then the value of y, of k I mean, we'll use the same coordinates of a to try and see that value. So g of x is given by k over x, and we know that x is less than 0, right? And knowing that, we also know that we have a point a, which is minus 2 and 9, right? So this will simply then mean that the y value is 9 is equals to the x value is minus 2. So that's k over negative 2. I solve for the k, it will be k is equals to negative 18. And then that's where you end it, right? You can always just end it by writing the equations. It's entirely up to you, where you say g of x is equals to minus 18 over x, right? With the previous one, you will say then it's 1 over 3 to the exponent of x. Now, if the graph is reflected, right, about the y-axis to form the graph of g, you need to determine the graph of h in the form of h is equals to, right? H of x is equals to. So the graph of g, remember we said this was the same as minus 18 over x, right? And provided that it's minus 18 over x, if I want to reflect this about the y-axis, it means I'm changing the x value sign and make it the different sign to whatever it is at the time. So I have g of x is equals to negative 18 over x. It means that h of x will then be negative 18 over negative x, right? Because the x was a positive, but now when we change the sign, it becomes a negative, which will simply just be 18 over x, and that will be the h of x. When they say to you in the form of, it means your answer must be left as h of x is equals to something. And then if the very same graph that we are using, which is g, and we are reflecting this in the y-axis now, instead of in the x-axis instead of the y-axis, we want to form the graph of k. This would simply mean that our equation is g of x is equals to minus 18 over x. And to reflect this about the x-axis, it means I'm changing the y. So it becomes minus g of x is equals to minus 18 over x. But I can't have a negative function value or function notation rather. So it simply makes it a g of x is equals to 18 over x, right? But remember, the g of x is actually the k of x, which is the new function that is formed. And this is a positive 18 over x. So if you reflect it in the y-axis and the x-axis, it will have the same effect to the mother function. And then the graphs of f of x and g of x are shown below. These graphs intersect on the y-axis, right? You can see they intersect there, although we don't know what that point is. But now what do I know on this graph? I definitely know that the x is equals to minus 2 will be the vertical asymptote. The y is equals to minus 1 will be the horizontal asymptote. So far, that's what I know, and that's what I'm going to use. So the point of intersection here of these asymptotes of mine will actually be minus 2 and minus 1. Now, the very first question will be they want us to find the equation of this, right, of g of x. So it will just quickly be g of x is equals to a into x. I know that my turning point is at minus 2 and minus 1. So this will therefore be plus 2 all squared minus 1, right? And then I substitute any point that I can find on this particular graph where I want to know what this equation is, which is where they're intersecting there, right? So in order to find the value of a, so I will need you to then try and see what this point is going to be. And that point will be the same as the y-intercept of the graph of f. And for it to be the y-intercept, it means x will be 0, so it will be 4 over 2 minus 1, which is 2 minus 1. So it will be the y-intercept 0 and 1, which is 1 is equals to a into 0 plus 2 all squared minus 1. If you solve for your a here, it will be 4. A is equals to 2, and then a will be equals to 1 over 2. So my equation will actually be y is equals to, or g of x rather, 1 over 2 into x plus 2 all squared minus 1. And then just the last question will be determine the equation of p of x if p of x is formed by reflecting this about the y-axis. If you reflect it about the y-axis, my x must change. So it means p of x will be equals to 4 over minus x plus 2 minus 1. And then you solve it so that you can remove those brackets there. Right, so that's what you guys need to please look at with these particular questions. Guys, understand that whenever you are given two graphs, wherever they're intersecting is the most important point. Wherever they're intersecting with the axis, especially the parabola, it's the most important points because it's the x-intercept. Wherever it is turning, it's the turning point, the axis of symmetry, your turning point of that particular graph. And your asymptotes, you really need to make sure that you familiarize yourself with that. Guys, I hope you've had so much fun, because I definitely have, with revising functions and looking at the overview of everything that has to do with functions. Please try to use your internet, your textbooks to try and see wherever you don't understand things to enlarge your understanding of functions. But from me, the Maths Doctor, to you, remember, mathematics is food for the soul. Until next time.